Well, thanks very much, Michael, for your presentation this morning. Awful lot of material to cover, and I've been studying it for 20 years now, and still learning stuff. But I think in trying to apply this to VISTA and where we are in our system, I think the most cogent part of it all was the difference between hierarchy and web-like or decentralized approaches. We were very much decentralized at the time, small type stuff. It used to be called the Decentralized Hospital Computer Program, and kind of stuck in the throats of people in the central office, so we turned it into VISTA. But, so that's one theme, and what's happening here is ever greater centralization happening. So the new generation is called the IEHR, Integrated Electronic Health Record, and they've mega centralized to both VA and DOD and the Joint Program Office, using the word agile at times, but totally waterfall development. You know that.
Water not so fall in this case.
Yeah.
Oh, it falls.
Water is power plants.
Water flows.
Exactly.
But so one topic I think is the balance between hierarchy and network thinking, and it goes all the way from the control structures to how it works to the data structures of how we structure the information. So that's one thing. The other one is the evolutionary systems issue of starting simple and growing it according to feedback. And I think Chris was telling us that about the goal was to get something good enough out there and then start the evolutionary process. And the more feedback you got, the more users you got involved.
Ready, fire, aim.
Yeah. And the VA has an incredible scale now. You know, for any given topic, it's got a world-class expert someplace in it, affiliated with 140 medical schools. So whatever you needed, you have in this community. So DHCP was very much this community focus, and we saw ourselves as a engine to support communities much the same way as Wiki supports the Wikipedia community. So I think that's another theme. And the patterns themselves, I don't think we were ever pattern language oriented. I didn't know about it when I started working in HCP, but
We were.
yeah, well, I think
We didn't know it.
yeah, I was very involved in a macro level, or a language one above the level of abstraction. If you look at the spreadsheet, for example, it's written in a programming language, and then it presents a user interface that can only be used for budgets or finances or travel sheets or whatever. But the design of the tool is very specific, but then it goes organic, if you will. And the spreadsheet designer doesn't care whether it's being used for or how it's being used, so there's an organicity level, of organic threshold, that you build the tools and then they take off on their own. So Word obviously do that with wikis, but what we're seeing from the bureaucracy is they're trying to do everything from a specific level. There is no organic threshold by which users can take off on their own. So I call this we chew, you swallow systems design.
You swallow.
My, that's vivid.
It could be more vivid, actually.
Every time we have one of these conferences, I'm stuck with a phrase like that. I will never forget that formula.
And the sense of beauty, to me, the initial VISTA architecture, 19 commands, 22 functions, and one data type, was beautiful. And it was a mathematical sense of beauty. It was very minimalized. We chopped stuff off in order to make it more compact. And this was kind of a virtual machine, if you will, that we could then port from one hardware to another or whatever, and then build our tools on top of it. So it's this sense of tool building and generativity, and using language to do it. So from my perspective, VISTA was always about building a speech community to facilitate communications about health. And the electronic health record was just one form of communication. It's also one of the most expensive forms, and probably the most fraught with potential for screwing things up due to the legal nature of our healthcare system. But anyway, I think the sense of beauty is a really fertile territory for looking at for the next generation, if you will. I like to think in terms of names. I create a name for something and I fill it out with stuff. So to me, I'm calling it MetaVista, which is a level above the current Meta system, or the VISTA system. I'm not worried about all the pieces below it. I'm worried about how do you move it up the level of abstraction, build more tools that pull it together in new ways and support where we want to go. So to me, it's MetaVista. And the metaphor I'd like to throw out as a design metaphor for discussion is rather than talk about integrated systems that's so popular, to talk about an information space for health. So it's a space metaphor. Got all this stuff floating around there. Some of it's in a hospital, some of it's in your chiropractor, some of it's in your dentist, but it's not locked into the hierarchy. It's this flat name. It's like the web, and everything has a name. You link it together logically rather than bureaucratically. So in that sense, we're building a space, and obviously it's not like an urban space or whatever. And that gives us a chance to talk about beauty and evolution and starting simple and moving up there. So anyway, these are just some notes that I had talking about your work. Rick, did you want to say something?
Yeah. Tom hasn't just given you a whole pile of interesting things to think about, and I'm about to do another one.
Okay.
But it will be familiar to you. And that is there are two related issues that Mr. Alexander talks about. One of them he talks about in The Timeless Way of Building and in the next one.
You got the microphone there, could you please use that?
All right. Sure.
Yeah, you're fading off.
Yeah, you faded
All right.
off.
But it's like
Fading back.
evidently I'm the one that beats this thing. So there are two related concepts I want to talk about and lay out there as Christopher DeMille. They relate to what Tom's talking about. One of them is in The Timeless Way of Building and in the next couple of books thereafter. Christopher Alexander talks about the fact that we look at the building as though the thingliness of it. And I'm not talking about it in the Bateson sense, but the structural, physical matter of it is the architecture. We think that the walls are the architecture, and the floor, and the joists, and the beams. And he says that's a misnomer, worse than a misnomer. It is a misconception. We're not seeing the part that matters. The part that matters is the movement. It's the space that's created as a result. It's where the matter is not. And that's one level that's missing from the way that we look at buildings. He says, but the even more important level is a level above that, and that is what matters about it is the relationship between the human beings, the things they do most often, and whether the space helps them to do that or gets in the way of it. It's the symbiotic relationship between the space created by the matter and the people going about their daily processes and lives. So that's one aspect of this that I think is important not to miss, because VISTA's design has a lot to do with going back to how you originally launched things, having things be user-driven, having things be developed in the field rather than on design specifications, meant that it came down to, well, what is it that you're trying to do that you need support for? It was very much actual human beings going through their daily lives driven design, which is very different from the exact same, we have a discussion about the exact same human beings sitting around thinking in abstracto or being interviewed about what do you think an EHR should be like, will come up with crap. But if you say, what do you need to do today? Will this help you? And you iterate exactly the same way that Christopher Alexander talks about in these books, you get the software equivalent of living architecture. That's one thing I'm going to talk about, or rather, check over as a pitch for your swing. The other pitch I'd like to check your way is in the second volume of The Nature of Order, The Process of Creating Life. He talks about the fact that you cannot get living structure from non-living processes. That the process itself has to be, the ways you go about building things can be categorized by how alive they are or how alive they are not. And they have to have a high degree of life as a process in order to be able to result in a living thing or a living structure afterwards. It's not possible to follow a mechanical, bureaucratic process like the IEHR process has so far been, and have, as a result, anything like living structures or sustainable complexity. So that's the two pitches I'd like to throw your way.
Well, let me start with that last one, which is, again, I think you see the notion, not just in Alexander, but the other people that I mentioned, that process and structure and static structure are the two sides of the same coin. The process generates the structure generates the process, you know, and so on. So if the structure, if you want living structure, you have to have living process in that. So because it's just simply two sides of the same coin. And so thinking about what kind of process is going to engage people and solve the problem that people have, well, it needs to, you know, be adapted to them. You were talking about how if you ask somebody in the abstract what is a good system, they're going to generate crap. But if you ask them, what do I need, they're going to give you the right answer, because it's an adaptive response to the real structure. That's their living structure, right? They're alive, and they're telling you what they need to stay alive, right? Or to, you know, continue. So I think a lot of this really boils down to, in a sense, common sense, but common sense applied to our problem solving in a way that we haven't necessarily done in recent past anyway, and sort of thinking through more clearly what is the sort of simple structure of what we're dealing with here. And you see that, I think, in Simon and in Jacobs and in a number of people that just sort of say, let's get down to the basic problem we're trying to solve here. What is it? And certainly that's the spirit you get with Alexander. And the notion that it's not just the architectural space or the architectural object, it's the processes of people moving through it. You know, he's definitely picking that up. I'm reminded of when Herbert Simon talked about a famous quote of his: a man viewed as a behaving system is actually very simple. The apparent complexity of his behavior is a result of the complexity of his environment. And that, you know, you can have a complex environment, you can have a complex hospital system, you can have lots of complexity in the result, but you need simplicity in the kernel of the process, right? And you got to focus on that. That certainly comes through very clearly in Chris's work. To touch a little bit on your comments, Tom, I was really struck with your conversation with Ward. I guess it was that conversation last year that you had online where he talked about we didn't want to create a kind of a portal and a hierarchical experience like you enter here and you do this and you do that. We just wanted to create a space. And I'm dealing with some software people right now, and they can't get their heads around that idea. They still think, you know, here's the client, he comes in, they do this, and it's, you know, they want to architect the experience, just like we architects want to architect the experience when somebody walks through the front door. And that's really the wrong approach, I think. It's what you need to do is create the space, create the sort of the kernel of the process that will generate all the complexity or respond to the complexity that's there. And I think that's really important. And then the other point that you were making about patterns, just to touch on that you said you weren't really aware of patterns. But I think I hope what you saw in the discussion of people like Simon and Jacobs and even Whitehead, and there's a whole bunch of people, Bateson and so on, a whole bunch of people who are moving in parallel on these issues. And I think Chris is incredibly perceptive and incredibly useful. But this idea,
The battery's gone. Your battery coming.
okay, well, anyway, this idea that he's a lonely prophet and he's just, you know, off in some space that he's created by himself, sui generis, you know,
Right.
is really a false perception, and it's one that I think architects tend to reinforce, because there's frankly a value in branding yourself that way. You know, you're Frank Gehry, you do this. You're Libeskind, you do this. You're Alexander, you do this, right? And that's actually a very destructive model for getting work done because it's non-collaborative. It doesn't say, I'm working in parallel to you. We have problems that we're both solving together and we can work together and solve them more quickly. The wiki way, if you will. Which is, I think, one of the reasons, frankly, why architects tend to repeat, frankly, building architects tend to repeat the same mistakes, the same kinds of mistakes over and over again. And then they just put a different aesthetic package on it. Again, seeing beauty as being something separate from the intrinsic structure of things, and call it good. And if somebody says, well, don't you see you're making the same mistake? The response is, well, no, it's totally different. Look how different it looks.
Very different.
So there we have it.
Can I relate this to the DoD system?
Sure.
They had a system called Trimus back in the 70s. They spent $250 million on 3 incompatible systems, and we call those the IOCs, or incompatible operating capabilities.
Yeah.
And then we came along, we had this DHCP system. We did the entire VA for $83 million, 100% hospitals, integrated and evolutionary. So they didn't like that because they wanted to do their functional decomposition. So we ended up putting DHCP in DoD, and they didn't like that either. It worked, and that was even worse. It came out really well. And so
He's not kidding.
the point where I really decided I was beating my head against the wall was when the program manager stood up in front of an audience of about 3,000 people and said that CHCS was too flexible. And I said, I haven't spent my life on designing a flexible system, and it would have been a career-limiting move to get up and express my thoughts at the moment. But anyway, so they started a new system called Alta, which was their way of doing it, and that's been coined, Alta is intolerable. They have congressional investigations against it. It's about a $5 billion waste. Same idea, same hierarchy, and then they're doing a new one called IEHR, which is exactly repeating everything that's failed. We do have an example of what worked, and people are ignoring it. VISTA was this
They're trying to change it into.
And it's like the bureaucracy and the hierarchy is just totally unstoppable, and they have this self-righteous indignation of anything that's not part of their hierarchy. You're not on our mission, or whatever they call it.
I heard at this conference a DoD medical professional on the record saying he'd rather go back to the field of battle than have to continue working with Alta.
It's third largest, second most cited reason for docs leaving military service. That's how bad the system is. Anyway, so that's a non-learning organization, and it just keeps going. And I think one of the papers that I was inspired to at least write the title for while you were talking was The End of the EHR, and we just can't keep going with pushing the complexity up this curve when we're already in a complexity crisis. We have to come up with something new, and somebody has to come up with it. And if you notice, Ward and I said that in our interviews, is all it takes is a few people with the right ideas. So that's kind of what I'm thinking here, is we need some right ideas.
Well, I think that's very hopeful and exciting, because, I mean, what it tells us is there is an open opportunity to solve those kinds of problems. We're not, at the mercy of these self-destructive processes and self-destructive institutions. They are certainly proceeding on the path they're on, and they're going to continue proceeding on the path they're on, because that's the way the operating system is configured. That's the way the incentives reward people, and all the crazy irrational things that happen as a result, as a very intelligible result of what seems at one scale to be logical, like the example I showed of the kind of crazy, absurd outcomes of things. And yet, I think there is a great space for innovation if you know how to do it, if you know how to step outside and create your own space. And that seems like what you guys are doing, and certainly what I hear from Ward, the spirit of what he likes to do is to just sort of take a very common sense approach, step outside of the clutter, and still learn from it. You're not reinventing the wheel, but you're you're also not imprisoning yourself in that operating system. You're creating a space that's far enough removed from it that you aren't caught up in it. And it sounds to me, from my limited knowledge, that that's what happened, but you're sort of getting dragged back into the operating system, and now there's maybe ways to step out again, and so it seems like there's that dynamic. Is that right?
Yeah, I think that's part of it. I call it searching for virgin territory to grow into, and I think we see that today in genomics, for example. There's no established bureaucracy for genomics. FDA is trying to screw it up, but there's a lot of wiggle space there in the whole social network. Facebook-y, Twitter-y type stuff that's happening is virgin territory too. So those are two areas that we could find some creative outlet into, and not try to attack the pyramid as you would. But I think the comparison with urban design is the notion of designing a space according to the people living in it and walking down the streets and everything else like that. And if you go to any hospital, clinic in the country, it'll have a vision statement that's we're patient-centric. Our mission is to serve the patient. What they're really saying is you come first after me. You have to pay us first, you have to register, you sign our HIPAA thing. So now you're part of our enterprise, and you're one of us, not them. And you can be really treated well, really nicely in Kaiser, but if you try to go to Scripps down the hall, or down the street, you're not one of them anymore. It's not patient-centered. So it's what I call castles and drawbridges architecture. And we have all these castles that HHS is supporting through the power structures and the hierarchies. So we're starting with the existing hierarchies and all the perversities of the current healthcare system, encoding that into the information system, and then building these drawbridges to try to relate things.
Brian Lord calls this medical feudalism.
Well, I'm reminded, so many of these mistakes and perverse outcomes seem to come from the effort to reduce risk and increase predictability, increase certainty, actually, when the system is not going to give you certainty by definition. And so you're sort of institutionally trying to throw a ball and hold on to it at the same time and make it go exactly where you want to go. And and so this is more of a kind of management philosophy thing, that there has to be some uncertainty embraced within the management, and some risk taking that says, we won't penalize you for taking risks, for stepping outside of the box and trying something. We'll create a space for you to do that, and that's part of our institutional culture to do that. And the institutions I know that do that the best are the most successful, I think, for that reason. But there are lots of institutions that don't, and it seems to me they're the most risk averse for various reasons, maybe because of political reasons, or they've been created through some kind of a fiat process that says, here's your objective, achieve it with certainty, don't come back to me if you haven't, delivered exactly this, which is a very top-down kind of agenda, right?
The Clear Cohen Act actually requires government agencies to outsource everything they can. Everything that they can't prove, they have to keep in-house. After Clear Cohen passed, a lot of breakup of the teams inside the VA began, a lot of focus on contracting out. And what's interesting about that is there's a couple of things. First of all, the DoD has been following the contract out model a lot longer than the VA has. And so in some respects, the VA moved to become more like the DoD, which they talk about openly, has a lot to do with the economic model. When you look at the economic model, the way the contracting offices work is, first they specify what they are going to ask for, and then people bid on it, and then they award it, and then they manage it to say, are you on time, on budget, and met the specs. That's the magical three things. When you look at studies of software project success or failure, like the chaos studies out of the Standish group, those are the three metrics they use there too. It aligns with the contracting structure. As we wrote about in VISTA Mastery, one of the things that's missing is, do the users like it? Does it actually help them? is not one of those three things. And in fact, you can't even make it fit one of those three things. It has nothing to do with any of them. You can be a success. And Chaos Report was pretty critical of software development methodologies. They really slammed us, and rightly so, because when they began doing the evaluations, the majority of software projects were at least partial failures, and something like 40% of them were complete failures, failed on every front. Now today, they'll tell you, they've reversed that, and maybe only 40% of them are partial or more failure. But that's only if you ignore whether or not it does anything useful for the user, because that's only as long as you measure on those three metrics. So what that does is it creates a distorting influence on the software lifecycle. You simply you can't be allowed under that structure to say, we're going to find out what the users want, because that's not part of the specification. The specification has to say, I'm going to deliver these specific things. I can't just say I'm going to make the users happier than they are today.
Well, that's the certainty again, that you have to define it. That's the certainty again, that you have to define the outcome in advance before you even let the process give you the opportunity to figure out what it is. And that I think does tie into the notion of beauty, that beauty is by definition not something you can specify, ahead of time. You can't say, this is going to be a beautiful blank. The process has to create it.
You want to say something, Chris?
Yes. One of the paradigms that the VA and the DoD has worked under for a long time is that they go out and they gather requirements, and then they start to work on it. And the whole cycle takes 18 to 24 months to do. And the same sort of thing that we were doing in the hospitals was taking hours, if not days, instead of months. And, and costing a fraction, a very small fraction of what they're doing with contracting. And it's been a disaster.
Yeah, there's an example just recently, a big problem with polypharmacy of vets returning, getting painkillers from the VA and the DoD and suiciding out basically. And to track that is a very simple 2 fields that need to be added to the DoD database. And the DoD assistant secretary said, well, we don't have enough money to do that this year, but it could be on the budget for next year. And this is put 2 fields in a database, which for fileman is about 30 seconds worth of work. But, David, did you have a comment back there?
I'm just saying that there's an issue of accountability that's part of this discussion. I mean, accountability in terms of, is something doing what you expect? In the terms of the contract, they think that comparing the end result to these specifications ahead of time is answering the question of why, and they're not. The question of why is a far more complex question. I mean, it's one thing to have code that says set variable equal to variable plus 1, calculate this value according to this, but it doesn't explain why you're doing it. You get to be a good programmer, you can read the code and say that for some reason he guarantees this date is later than January the 1st, 1989, and then he guarantees that the last time any date has been put in was 6 months. Why? Well, just because he's doing it. I mean, there's more what in the code than there's why, and trying to capture why is an essential part of this whole question about contracting. It's a question of purpose, and I didn't want to interrupt your conversation about adding the extra couple fields to DoD, because I think that's an important issue too. But I just wanted to bring up this issue.
Well, I think I've read stories that people who've gone to the EHR have specifically cut back on informal conversations with the patient because they're afraid of liability incurred by discussing alternatives and, hi, how are you, whatever. And so the risk model, the liability, and this notion of the normal distribution, that everybody is a scalar value deviation from the norm for a given factor, is just driving all this in ever deeper hierarchical reductionism. Back to the notion of beauty, I've been asking people about beauty in healthcare, and 3 things have popped up so far. One is hospice, and people talk about hospice being a beautiful experience. Grandma died, but still it was a beautiful transformative time for the whole family, and is humane, all these wonderful characteristics. And the critical turning point was when we're going to work on quality of life, not longevity of life. But it was also the sense of connectivity with a caseworker and this sense of community around a topic. So that has been a really strong recurring thing I've experienced twice in my family. Another one is AA, Alcoholics Anonymous, and people saying that it's been transformative and it's been a beautiful experience for them. And again, this is an organization that started out with too little money. Rockefeller refused to fund them fully and made them this. And it's also this community-based thing. It's people connecting with each other. And the other one is the French healthcare system, which I've heard mixed reviews about how good it is, but what comes across really strongly is the sense that the doctor is your friend and a connector, and he's a local community member, and you have this connection with your physician very closely, and it's not your adversary, he's not a gatekeeper, he's a partner in health, or she. So those are three examples of beauty in healthcare, I think, and the underlying thing is this sense of connectivity and community and participation. Anyway, I'd just like to throw it out. Does anybody else have any sense of beauty in healthcare that they'd like to talk about?
It's orthogonal. In that, and I'll pick up the phrase I talked about yesterday, is there's a lot of beauty in VISTA. And I'm inspired by some of the prescriptive things that you presented about what it is you need to do. That have been the thinking about it. And I've been trying to, as you were saying it, I was trying to relate it to concrete things that we are doing or that we could do, and see if in fact it could crystallize, put it in shape, see it in a new way. And so I did that, and so I'd like to get feedback on that. And the following, there's two aesthetics that I think are really germane to how we design and engage, begin to engage in the evolution of VISTA. Because I think that's really, DOD and VA can have all kinds of words about things, but in the end, what we're talking about is how we evolve VISTA to meet the needs of all the parties that it needs to serve. So, so I think, so I read, you can see all these charts and things. Those are just basically big complaints about things it doesn't do that I need done. So I just read them as that. They're not solutions. They're just big charts of things that it doesn't do yet. And so now, I think we're almost getting to the point where people are recognizing you can't throw VISTA away, that you have to in fact evolve it. So the question is, how do we evolve it in a beautiful way, in a way that is organic? And so the two aesthetics I was thinking about. One, and I don't have the right word for it, but I'll say several things that occur to me that I think are all wrong. Under the aesthetic of conservation is not quite right. It's the aesthetic of renovation. So this is the aesthetic is how much of what already exists that is of value do you incorporate into your new, into what you're doing, into the new solution. So the aesthetic is the more of what exists today that you can use in what you're proposing, the more beautiful that is. So it's more beautiful because it leverages more of what exists and is proven and is used, and et cetera. So that's one aesthetic. The second aesthetic is this aesthetic of place, which I thought up there. I said, my God, that's incredible. So we've got, so the aesthetic of place can be applied in software as to where do you locate and do the thing that you're doing. So you can measure a thing that you're talking about doing and then talk about it in both these terms. It's more, and so the aesthetic of place is the principle of locality. Some people have talked about it. So how close to where it's needed is it being done? All right. So we got aesthetic as place and aesthetic of conservation or aesthetic of renovation. I would love to have one good, really term for that, I don't have it, so.
Sustainability is one of the terms that they use when you renovate.
Yeah, but that can sustain, things could be sustainable without using anything from the old improvement.
You'll find Michael has something to say.
All right, so.
Well, I was just going to say, I think that's fantastic, what you just, both of those things, but the idea that by conserving something it's automatically beautiful, I would qualify that. I would say the beauty emerges from the conserving because you're conserving what is most beautiful or most likely to be beautiful, in the sense that it's likely to work, it's likely to be elegant, it's likely to be enhance the qualities of life, and so it's kind of a, it's not just beautiful because you conserve it. It's the beauty is the kind of aesthetic that you apply as a qualitative test to what you're conserving, right? And the more you can conserve that is beautiful, the more beautiful the whole thing will be. And therefore, the corollary of that, which I like a lot, is that the more you prune away that's not working and that's ugly, literally ugly, the more effective the result is going to be, the more beautiful the result is going to be. And I think any mathematician would tell you that about a theory, any coder would tell you that about code, right?
Yeah, a couple points here. One is the locality issue in one of my observations in the VA, working at the departmental level, the hospital level, the region, district, national level, that everywhere I went, people wanted things decentralized above them and centralized below them. And so it just migrated all the way up to Congress now, and everything is centralized below Congress. And I call that the anchor point. And in DHCP, we established the anchor point as the hospital. And we had 1,200 watt modems and 5 megabyte disk drives, and putting a hospital in one anchor point was the right issue at the time, I think. And then we networked the hospitals from point to point. But this sense of an anchor point might relate to your locality of where do you anchor things. And I think the real answer is you anchor it at the patient today. And today it's the patient. And maybe the gene tomorrow. It might be that the genetic level is the anchor point, or at least a key part of it all. I haven't resolved that in my head yet, but I don't think we've hit the bottom of smaller and smaller, finer granularity in a large scale. So I call it large scale fine grain network. But that doesn't mean you still can't have a centralized system. You can still have a national system that rolls up, and you can add up all the blonde-haired, blue-eyed, sunburned melanoma cases, and that's great. You can do that, but you don't start with the melanoma department, and everybody has to categorize themselves. But anyway, so that's one issue, and the other one escapes me. But I don't know. Did you want to say something?
Sure. One of the things Christopher Alexander talks about, I think more in a pattern language than in the timeless way of building, is the idea that when you're renovating, you want to preserve what works. And I guess it's not that book, is it? It's the organ experiment. He says you want to.
All three, to some extent, the idea of piecemeal growth and
yes,
conserving.
Yes, piecemeal growth.
Site repair.
And the idea of a diagnosis.
Yeah.
The idea that you understand what your patterns of health and beauty are, so that you can diagnose the system you have and identify what's beautiful and what's in trouble. Where are the pressure points that need work? And that's where the new beauty unfolds. In a pattern language, he talks about site repair. That pattern struck me dramatically. He says people will buy this property with a hill and an ugly swamp down below, and now let's put the house on the hill. But the hill was already beautiful. Why did they do that? In fact, the hill's a little less beautiful now that they put the house there. Whereas the swamp needed help. If they put it down below near the swamp and developed the area to be gorgeous and a pond and all that, the whole thing would have gotten more beautiful. But they were drawn to the beauty and they erased it. They wanted to replace it. They kind of stopped themselves.
I don't know if this is a word George would like, but I found a nice word, which is cultivation. Cultivation, because that can that thing of
Well, the
improvement,
care.
but also of care and leading and so forth. So you're doing both of those things of retaining the value and improving while getting the draw set.
Yeah, it does. It touches on a lot of the ideas.
And that's very much in the spirit of what Jane Jacobs has been talking about. And there's a movement now called economic gardening. It's very interesting. It's the idea that, again, you treat the problem as a kind of gardening kind of a problem where you're cultivating what's desirable, you're pruning away what's not desirable, you're using genetic seeds, you're using fertilizer and water and so on. There are a lot of analogies that are pretty spot on, really, in terms of a methodology that works better for that kind of problem, the cat problem rather than toaster problem. And there are, I think there's direct, not only design corollaries, but management corollaries. The idea that you do have to sort of let it grow and maximize the quality without knowing what that means, which is antithetical to the idea of hierarchical control. Because and I'm dealing with this right now on a project here in Washington State. Actually, there's the SEPA process, which is a State Environmental Policy Act. It's an EIS process, and we're being asked to look at a couple of different scenarios for a redevelopment of a site or development of a site. And we have to say, well, when everything is done in 20 years and this house is here and that house is there and it's just exactly like this and like that, this will be the impact. As opposed to that over there will be the impact if we do. Well, how the heck would we ever know such a thing, right? It's a catch-22 kind of problem. So if you change the criteria from the quantitative evaluation of an outcome that you can't possibly really predict, which is just creating make work and clutter, to a qualitative outcome, to say, well, we're following the process that we know is most likely to improve quality, and here are the safeguards, and here are the methodologies, and just like any gardener would do to say, here's how we grow plants around here. I mean, it's pretty commonsensical stuff, really.
I've been developing the dichotomy, I call it search amplify versus plan execute.
Yeah.
And the plan execute model came out of my thinking of humanitarian activities, but eradicating smallpox was a plan. We figured out the vaccine, and then we executed the vaccination program. Great, worked really well. Some things do work that well, and they tend to be more toaster-like. The search amplify model is you don't know exactly the solution, but it's a matter of discovering what's working and then just doing more of it. So it's a simple gradient process of, well, this seems a little bit better, let's put a little more energy into that. And it cascades up. And if you have a large enough space to discover these things, it's a power law distribution. There's something way out there in the distance that if you just give it a little bit of attention and energy and you amplify it, it will cascade up and become a very prominent thing. So it's more of a evolutionary ratchet model or something like that. And this dynamic, I think, is, first of all, plan execute is the overwhelming thought process. We'll plan this ecosystem, we'll plan the pond, and we'll execute the program to keep the algae down, whatever, I don't know. But the discovery process is way underappreciated, and particularly in hierarchical control structures that need to have a single metric to drive things. But I think putting that into the healthcare system, let's do a search process. And a company called Cure Together is similar to that, and they have self-reporting symptoms. What do you do for insomnia? This, and 1,500 things. And turns out masturbation is generally fairly effective. Now, did the FDA do masturbation for insomnia? Probably not. But it comes out in the Facebook world, and and the other interesting thing about this, they have a quadrant of most likely surprising but frequent, surprising infrequent, infrequently effective, and the 4 quadrants. Anyway, the surprisingly effective quadrant typically is stuff that doesn't have the economic incentive. It's not the drugs, it's exercise, it's diet, yoga, whatever. But the drugs typically are way down on the effectiveness scale, but they're very popular. You don't wonder why. But anyway, Cure Together is an example of the search amplify model applied to symptoms and things like that.
They did a study on in a hospital ward, a randomized study of a couple thousand people. Half of them got an old woman bringing them chicken soup every day, and then at the end of the program, they saw how well they recovered, their satisfaction and outcomes, and they were much better. And yet, medically, there's no reason to explain these better outcomes except the patient's involvement. If I could see one, and I think the way the systems are set up now, EHRs are largely between the provider and the payer. The patient sometimes doesn't even look to see their medical record without specifically asking. I think it'll be a great improvement when the patient at least can read everything that's in their EMR on a regular basis, because a lot of it is, frankly, self-serving by the physicians or the people entering the data.
I think what you touch on is the notion of tight feedback cycles and you know, small-grained adaptations that can become large-grained if you need them to, but you start there. And I'll give you an example from the planning world. Transportation engineers have typically been doing things in very sort of large-scale, top-down ways. Here's what a safe road is. Here's how you create the intersection, and you have signals, and the pedestrians have to stop, and there's a gate, and there's a this, and there's a that. And they found to their surprise that the more they add those things, the safety did not improve. It actually, people were paying less attention because there were more, you know, more of these signs and controls and so on. And that actually, if you remove a lot of those, at least in low-speed environments, and you get people looking at each other and making eye contact between motorists and pedestrians and bicyclists and so on, the safety goes way up. And so there's a whole new generation of what are called shared space designs now that are low-speed intersections of that kind, and they work really, really well. But they work because you allow people to get together and self-organize their responses to each other and say, oh, we've got to be careful, there's a child there, and you know, so on. And you allow that system to regulate itself. There's an interesting thing that Tom reminded me of this when he was talking. There is a place for, you know, toasters and toaster-like problems and regulatory problems that we all get together collectively and we say, hey, we've got to control pollution and we've got to limit how much everybody can emit or something like that. I don't think we can deny that. And there's a place for saying, well, let entrepreneurs get together and figure out how to solve a problem and make some money on it, and there's a place for that. But somewhere in between, there's a whole third realm of what you might call cultural processes between the political and the private, if you will, where a whole lot of great problem solving occurs on this kind of cultural level, the wiki-like level, where people get together and grapple with larger problems as well as smaller problems. And I think science is another institution that's grappling with these same kinds of issues, and how do we cut through the sort of the bureaucracy of waiting for a journal publication to go through peer review and you know, wait 2 years before anybody reads it and deal with all the complications. Can we create a kind of a science 2.0 that is much more efficient and tighter feedback loops and people learning from each other more quickly, involving maybe some you know, other evidence out there that we're not paying attention to yet, creating ultimately a more intelligent kind of a culture, kind of a methodology.
Well, I mean, isn't that what you're talking about the sort of the piece of science that we don't know? Right? I mean, isn't that really time where what you're talking about, and basically what you're talking about is being able to see information that is sort of outside the human limit, the intuitive grasp, where, you know, where it can be aggregated and presented in such a way that it provides an insight that we would not be, normally would not have available to us.
Like the Framingham study.
Yeah, that's really the core, I think, in many ways. And if you look at science, there's been kind of two factions. One is the F equals ma stuff. You have particles and forces and masses and acceleration. It works really well if you're sending a rocket to the moon. Phenomenal, you know, or Mars or whatever. So but that's discrete elements that can be dealt with as masses and accelerations. The other is thermodynamics and gas and pressure and volume and particles bouncing around, but you can't track each particle anymore, so that's a statistical world. But there's no context outside of the gas, if you will. So the gas being dissolved in a pond in an ecosystem, all bets are off now. It's not a thermodynamics anymore, but are we feeding the predators or the prey? Are we feeding the algae that's going to create the methane? What all this stuff going on? We don't have the intellectual paraphernalia for dealing with this level of complexity. A lot of people are looking at it, talking about it. And in healthcare, we've tried to resolve it all with this normal distribution and bell curve medicine. Let's define it all as a single variable, put it in a normal distribution curve, and talk about deviations. And add up all the deviations, and somehow that's the whole. So that, to me, is the fundamental gap in our knowledge and our way of understanding healthcare and causality and this notion of cascades instead of cause. Things that have this, you know, like allergy. You know, you can go along well and be near a cat is fine, but then you're near orange, the cat screwed up your allergy system so that the orange blossom will trigger it or whatever. So there's this cascading effect that happens in spades in genomics. You know, you have a sperm and an egg, and you have a next Albert Einstein happen. You know, that cascade is an amazing sequence of things, but it's not a cause. And then again, this Eric Topol at Greater Destruction of Medicine is really on top of that. I would say really on top of it. He's pointing that way. And James Fowler at UCSD with his connected to framing Mark data study of looking at the social network interactions of people and who knows whom and how it's affected each other. So the VA has the scale to deal with these things in very innovative ways. And we have 30 years, 40 years of data that might appear kind of junk-like and noisy and all this kind of stuff. But it's the stuff that we could data mine and find out, well, who was on the north side of the hospital on the sunny hospital bed versus the shady side. And after 40 years, you can look at the effectiveness in those rooms and, you know, I think it's a pretty simple query.
Yeah.
And maybe PTSD is related to a seasonal affective disorder. And you can go back and find out what was, you know, I mean, there's just so much richness that you could get by looking at these associative qualities rather than the integrated qualities. And so the current normal distribution model would not be able to see that. And my fear is that the VA is not keeping its historical junk data in order to categorize it and throw it into a health data repository. The more I think of it, maybe the IHS is where it's at after all. Maybe we have all that, and I hope you're not throwing anything away.
Well, would it not then follow then if we, I'm kind of a results guy, you know, sorry, but I mean, what we're trying to do here is you know, we're talking about and trying to examine some ways to, you know, how, in other words, that's a great theory. How does this apply? Right. So really, what we're trying to do is, you know, would it be possible to try to establish a common set of goals so that we understand it? In other words, so that everyone that's in the room, when we leave out of here, we leave with the idea that there is a reason, and it's a way of aligning everyone's energy to pull in that direction. And you know, so because the next thing that happens beyond this, you know, this outside of the intuitive thing, then of course is then the reporting gets faster. We begin looking at you know, wow, you know, we're going to be able to get real-time clinical decision support. You know, I mean, there are all these In other words, there's layers of this stuff out there waiting on us, right? And so, you know, I want to jump on it. Let's get to it.
So, yeah, I want to throw something into the pond here and see if there's some ripples. What we've been working on the last few years, just kind of a piecemeal, is the concept of being able to take VISTA and make it into a convenient prototyping tool to explore the kinds of things you're talking about. You know, that we can't do the population data because that's inside the VA. The VA could choose to do that, but there's stuff that we can do. The stuff that we can do, we can mine VISTA, you know, and we can use VISTA, try to use VISTA, try to pick out the beautiful pieces of VISTA, reassemble them, and see if we can get them to address some of the challenges and problems we'd like to see them to do. And I can be specific. I mean, I'll tell you the specific things we did, and you know, and actually try to map them against the things you said we ought to need to do. So the first thing, we have a prototyping thing, which is Dewdrop, which is this virtual machine that anybody can download from the internet, so that anybody can prototype on. So if we're successful in making this a prototyping environment to address bigger problems, the mechanism we're trying to do is we put it in a virtual machine so anybody can download it. The next step is that if they prototype something that they want to show to others or share with others or combine with what others are doing, we need to be able to you know, allow them to share that and put, you know, maybe in a common thing. But what, or you know, the what, goes back. I just wrote a triple store for VISTA in months. So with the idea that what I was struck by was that subject object predicate, the computer science result that things of arbitrary complexity can be represented with that mechanism. So if you can support triples, you can support a thing of arbitrary complexity. And then, in fact, you can represent a graph, you know, and a network of graphs. And you can have predicate relationships like the kinds you're talking about, the associative stuff you're talking about, as well as the subject-object pointer kind of constructed. So you can have, you know, you can have a bunch of graphs constructed with pointers from each other, you know, subject-object stuff. But then also you have the orthogonal predicate relationships. There are, you know, some of them unknown, some of them planned. And you have the notion that you could have a set of graphs put together to do a certain purpose. And then you can use that purpose or use that set of graphs for a whole new purpose without interfering with them, without having them have to change it all. You know, by leveraging the terminologies, the predicates, the objects. So you can create your own new graph, which all of a sudden turns the whole thing on its head with a new view. So that's really powerful. Locality, then, is let's take the ability to represent graphs and put it right inside VISTA. So let's be able to have graphs and really, you know, as many graphs as you want and do graph and have graph operations inside VISTA. And then let's have a mechanism to connect that, to leverage the locality of that and be able to leverage the interactions of those graphs with some of the most powerful and beautiful parts of VISTA. So for example, the event processing. So one of the most beautiful parts of VISTA is there's a publish and subscribe mechanism which is designed into VISTA where around the protocol file. So there are clinical events that are defined in the system. And VISTA has a beautiful mechanism where if there's a clinical event, you have a new thing that wants to occur when that clinical event happens or wants to be informed by that event or whatever, you can just subscribe to it. You don't need to change anything in that event process. You subscribe to it and VISTA supports. So if you can prototype a set of graph transformations, a set of graph things, you know, so and anything can be represented in a graph. So you know, sort of the complexity of the thing you're using. So if you define a set of graphs, and you can actually just in VISTA subscribe that graph process to a clinical event, and all of a sudden now you're prototyping an extension to VISTA, which in fact may not go into production that way. you know, eventually the end point of that is you may understand a new requirement that needs to be, so when you refactor a part of VISTA, you know what it needs to do because you've already prototyped in that environment. And you start to grow VISTA and make it stronger by using it as a prototyping tool. And educate people, you know, who would then be able to actually do the work of extending VISTA in all these myriad ways that the DoD and VA is telling us it needs to be extended. I mean, there's just stuff that has to happen out there. Some of the stuff has to happen inside VISTA. Some of the stuff indeed has to happen, you know, in some site way in, you know, it may be locality. I mean, it has to happen in the battlefield, you know. Yes, there's messaging, and I think messaging is one of the largest. And in a second, I'll give you this thing, because I got one more thing to say. All right.
I can't remember, I can't stack all my answers.
I know, but that's why I want to open this dialogue. So, but I want to put all the cards on the table. So we got the triple store. We can start with multiple graphs. We have dewdrops, so everybody can use this. We have, and it can share because it outputs RDF. So if you make a graph, you want to show it to me, you send me the RDF, just load it in. We have this one capability in VISTA where we can hook the graphs together without harming VISTA, without changing VISTA at all. We just subscribe to an event, and we now have hooked with this new prototyping capability. And so normally what the protocol file does is send HL7 messages out or get HL7 messages in, right? And that requires a lot of programming. What's a free-form HL7 message? You know, and so messaging is, very clearly, many of these processes with a prototype are going to result in messaging. And you've designed and created and put as the heart of VISTA the network mail and messaging thing. So I envision a really fertile area is new logic based on events that occurs with messaging between patients and the kind of ecosystem you're talking about. So we could prototype all that by downloading Dewdrop, creating it, and having the messages flow. See how they flow. See, so one graph might be a way to construct the message you're going to send, you know, et cetera, and then the recipients.
Yeah. Okay, I'm sorry. 6 levels of my stack. One is the HL7 is the messaging standard for hospital systems. It's based on the notion of a transaction happening when something happens. So there has to be an action and it's a response to it. Well, things that don't happen in the hospital are frequently more important than the things that do happen. That's missing nothing. So you forgot to do this. You left the patient in the hallway. You left sponges in the surgery. So tracking what doesn't happen is really critical. So I had a whole concept called the pendex of pending index of things that are expected, and then you check them off when they happen. But this pattern like generativity of saying, well, this is one of these patients, we expect these things to happen, and if they don't happen, let's find out. I mean, there's very clear protocols that you could write for, you know, you have a heart attack, you need to get this thing here or whatever at that time. So that's good stuff. But anyway, finding things that don't happen is really critical. VA just released an RFP for someone to archive VISTA data, and Mike O'Neill just sent it to me. It has to be archived for 75 years. Why 75? I don't know. But
75 years past the lifespan of the patient.
Yeah, but I mean, why not keep it in perpetuity? I mean, why throw away 75 years of clinical
Maybe because
information?
the paper would degrade over 75 years.
Some silly reason to you. Some very silly reason.
In any case, it brings up exactly this problem of how do you capture all that. And the first thing I would say is just do a global dump and keep the pumps interpreters around. But the next problem is synchronizing the data. So if you want to do the north-south study of the hospital outcome assessment, maybe the north rooms are even and the south rooms are odd numbered. Well, what if they remodeled the hospital in 1998? You know, how do you map that? How do you find that out? And so I call this a diachronic information system as opposed to a synchronic one. So synchronic is where everything is at a snapshot in time. You've updated to the latest release of Windows and Firefox, and you're synchronized. Diachronic is that it changes over time. And
The idea I had with mumps was to turn globals into a diachronic scheme is just not ever delete any data. So when you update a database, you put in the new data and a timestamp on it, but the old data is still there. And you could set a virtual time pointer, say as of last June, what did the database look like? So you could just go back in time and see everything. The key is you're not erasing old data. Turns out it's a whole lot simpler to design a system around that for lockouts and everything else, so it actually simplifies things.
The new lab systems being designed exactly like that.
New what?
The lab guys in the back room here,
Yeah.
that's exactly what they're going to do in lab file.
Yeah, I just do it at the mumps global handler, you know, so you just never erase data, you know, and yes, the change log on the wiki, and the Pendex is the future changes. What are we expecting this web page to do? So you've got the history, and then you've got the future. Yeah, and then that's actually part of the way I like the wiki structure is it is diachronic in that sense. How are we doing on time?
Well, we're good. We've got 20 minutes. We've got lots more to talk about. We're doing all the talking up here.
One of the major problems that the VA has been doing is the centralization aspect, where the data center goes down and we lose 18 hospitals. And all of the patients and doctors are sitting in their offices and halfway through a patient record, and now the lights have gone out, and a whole bunch of records are left in a halfway state. Now, one of the wonderful things about VISTA is that it will all fit on and run on a laptop. A desktop, laptop. It doesn't take much to really build it. Now, what I'm projecting is that there should be the ability to complete the transaction locally. I'm giving this pill to this patient at this time, bang, that's a transaction. Now it's encapsulated and sent up to my parent. My parent receives that and then replays it against his database with the patient already in it, because he was the source of how I got that patient's record. Now, and then he has reported that transaction up to his parent. And this is et cetera, until we get to a national. So every delivery of a service to a patient can be logged that way. Not only that, but this makes the whole system very resilient to the failure of the network. Any of the parents, you can reconstruct almost identically what any point of care was, from the list of parents, and even from the national. And the nice thing about that is that you can now do a mirror of all that patient information to another site and do all kinds of data mining on it. And it is consistent data, because it is being replayed at each of the parent levels. So, backup is almost trivial, because you can do it at the national or at any of the parent levels. And you've not impacted the point of cares at all. And if they do get isolated, they just stack up those transactions until the network is healed. And then they all go up. But this is one of the things that is so wonderful about VISTA, is it's small. I've actually seen most of VISTA loaded onto a one laptop per child laptop, which is pretty doggone austere. But
how much data was in that though?
Not much.
Yeah.
Yeah, but the thing is that now you could put a 128 gig chip in there, and you've just essentially built yourself the capability of running a clinic.
Unless you're doing imaging.
Huh?
Unless you're doing imaging.
Well, yeah, but also some of the things that you can do is carry along a picture of the patient. You want ID? Fine. It's just a guy who's sitting in front of you. You know, it gets a little, it doesn't get much easier than that. And, you know, so there's a lot of things that could be done that really make the whole model much more dynamic and expansive, because you need more computing power, add it on at the bottom. Just introduce it to new parents.
Well, that's exactly the architecture that I think, you know, all of this discussion points towards. A simple kernel, lots of copies, right? That's what Wiki does. You know, you have a very simple kind of structure at its heart, and then each page is however long it needs to be, and then you've got all the edits, you know, a long, long trail of the edits of what happened to that page. So if you need to go back, if you have any problem at any point, you can quickly figure out what it is. But you at its heart, you've just got a very simple, you know, simple rules, vast complexity kind of thing.
So, I'll steal the microphone for a few minutes. I want to run through a couple of ideas. These come out of the idea of living processes. If you want to have a living process, you need to have a feedback loop. If you don't have homeostatic mechanisms to push things back into normal when they deviate too far, then you can't maintain blood pressure, blood sugar, whatever the issue is. This comes down to the issue, and the problem is when we talk about feedback loops, we have a tendency to talk about them in arbitrary, abstract terms, as though we could have one because we wanted to. I feel like there should be a feedback loop, therefore it is. For example, a change management, which is based on the theory that, I've heard that there should be a dialogue between managers and their employees, so the managers will tell the employees, you know, what's going to happen, and then we will get them to buy in, and that's a dialogue, they think. Right? Just because we call it a feedback loop doesn't mean there is one. For there to actually be a feedback loop, there has to be conflict. There has to be creative pressure, creative tension. All of the biological systems that maintain homeostasis do so not because somebody said our blood pressure should be kept even, but because there are opposing drives in the body, opposing sets of nerves, opposing sets of hormones, and so on. A simple example that I cite on the blog that I write about this stuff is blood sugar. You've got insulin, which is going to drive your cells to soak sugar out of the bloodstream and therefore drop the blood sugar level, and they store it. It doesn't ban it. You know, we tend to talk about it like it disappears and teleports into the cosmos and yay, no more sugar. That's not what's happening. It's storing it in your tissues. But you also have glucagon. If you go too long without eating, your body's going to dump glucagon into your system, and that's going to tell your cells to release sugar back into the bloodstream. There's a balance. So for example, if all you ever do is shoot up with insulin and you never fast, you're never hungry, glucagon is never going to soak the sugar back out of your tissues and into your bloodstream. Tissues are going to get more and more saturated with sugar. Their ability to absorb sugar from bloodstream is going to go further and further down. And of course, our current way of describing this situation is to say, there's something wrong with his pancreas, that the insulin isn't working, he's resistant. He's not resistant insulin, he's full of sugar. You know, so you can't keep pouring sugar into the storage location. So the point is, these kinds of feedback loops are what create living systems. The homeostatic mechanisms do it. They have to have things in opposition to each other. There are a pair of pairs. Let me back up and say this again. There are two different homeostatic mechanisms I'd like to talk about with us, if that's all right, involving the VISTA software lifecycle and how it informs and drives the software lifecycle. When Tom's trying to understand what has gone wrong in the VA, why did they do this, I think part of it is both of these feedback mechanisms have been disrupted by the VA. And the process of getting to the new beautiful architecture, on the one hand, we can do it prescriptively and say, well, I think it ought to look like this and it ought to have these things. But then we're doing exactly what Christopher Alexander says not to do. What we could do instead is restart those homeostatic mechanisms and then just feed them, and this goes back to things Thomas said, with carefully chosen but very simple initial seed conditions from which order can emerge, like in the design of the internet and how links work. So there's two I'd like to sketch real quick. I'll do it real quick. And both of them have to do with conflict. There are two big conflicts. I'm going to use two separate sheets for this. The first conflict is between innovation and my apologies to those of you who share an office with me and heard me say this like a cajillion times. Innovation and standardization. these are opposites. They're opposites. Because if everybody does things the same way, then nobody's innovating. Right? They're doing it the same way. Innovation is the opposite of standardization. Standardization drives out innovation. Innovation drives out standardization. And in mechanistic software life cycles, in which all the instructions come from one place, organizations usually choose one or the other, and almost always choose standardization. Because if they choose innovation, if they just say, everybody do what you feel like, well, it's like he said with Trimus, 3 different departments go out, get 3 different systems, and they don't work together. So invariably, they lean overly hard towards standardization, and it drives out innovation. It causes paralysis in the software design. It also causes the kinds of stupidity Christopher Alexander writes about. In the initial conditions of the design, before we have any contact with reality, we try to think our way to success. Instead of science, which would be rational empiricism, we should go for reason. We think we can reason our way to a solution in advance of the evidence, and then lock down the design and force everything to conform to it. This is what comes of this. So what we actually want is we want both of them, and we want them to be fighting in a way that's constructive, that creates a feedback loop, a living system. And there is a way that emerged in VISTA to do this. It was not explicitly part of the original design of DHCP before it was called DHCP, back in the underground, in the late 70s and early 80s. But everything about it was set in motion then. It emerged during the 80s. And it works like this. It's not that hard to explain. The first is, you'll recognize this because this is the napkin. What restaurant was it that you were in where you drew the sketch on the napkin of the onion diagram?
Coffee Gam's restaurant at Loma Linda.
Coffee Dam's restaurant, Loma Linda. You remember the year?
What now?
You remember what year that was?
1978.
1978. So, 1978, he solved this problem. He was trying to do something slightly orthogonal to that. He was talking about the basic architecture. But it turns out the basic architecture can be driven by this software lifecycle, which emerged much more clearly as soon as it was deployed. As soon as we had hundreds of hospitals trying to innovate and therefore creating problems for standardization. So here's how it works, very simple. We have a core, just like the internet does. The internet has a core of standards. We have a core of software that has extensible frameworks. For example, how you store data. We have one database management system. All applications store data the same way. We don't tell them what data to store, just like Tim Berners-Lee and the internet. We don't say, here's exactly what's going to be in there. We say, whatever you're storing, you're going to store it like this. Yes, exactly.
That's actually called the kernel, Michael.
Right. So we can think of this as the kernel. And this basically says the sorts of things that can happen, but not which things they are. So it says things like, for example, if a user signs into the system, what do his menus of choices look like? Well, we've got a module in here that says, well, I don't know what it is you want to give your user the ability to do, but whatever it is, this is how you specify it. You lay it out like this. Same for files. Same for he was talking about protocols, the events, clinically significant events. We've prescribed the drug. Okay, if anyone cares, they can subscribe. I don't know who's subscribing, but I fire the event, and whoever cares about it wins. Or the drug has been filled, or the drug has been picked up. These are events. So all these kinds of things are in here. Meanwhile, in this outer core, anybody who wants to can use this extensible framework to innovate. Right? That we don't know what they're making. They can make anything that they want to. Most of what they make will plug in nicely into these extensible frameworks. But some percentage of what they make, there's no extensible framework for, because there's only some people making the kernel, and there's lots and lots of people innovating. That's why it's a difference between standardization and innovation. So the people who are innovating will also come up with things we never would have thought of. And if we are doing our job right? Well, the tension that is created is the system gets more chaotic as more and more of this stuff gets introduced that doesn't fit anywhere into the core architectural framework. This is the stuff Tom's been talking about.
I call it organic threshold, that inner circle. Once you go outside from the kernel to those blobs, that becomes organic, invisible to the initial kernel.
Right. So the innovation starts at, some forms of innovation lead us to extending the standard in beautiful ways that we can't anticipate that do an internet-like thing, but some of it leads to some chaos. So what's supposed to happen, the solution to this problem, to avoid either stasis or just endless chaos, is that you have permanent teams working on this, and they are watching what everybody else is doing. And as a result, when they see a pattern, they see a bunch of applications doing the same thing in different ways, they say, this is our opportunity to standardize. We will extend the extensible frameworks like so. And now, all the application developers,
And simplify their approaches.
it becomes a plugin. You get rid of, 3 or a dozen or thousands in some cases of blobs, and they go back to, they become a new form of order that unfolds out of the center. And then again, it doesn't unfold in a rigid way. It unfolds in a way that says, now there's this new capability. Anybody can take advantage of. Anybody can extend it. We don't know what they'll do with it, but we know this is a pattern. This is the discovery of patterns in the software. And we open up the pattern and people exploit them to the
I
fullest.
call that creating a path of least resistance. So it's just easier to use the red star than to go up and invent your own.
Right.
Exactly.
But you
Well-
can start by inventing your own system and then pull it in.
Yeah.
Exactly.
Yeah.
So there's a similarity to get there, isn't there? The idea
Yes.
that
Yes.
you pull it off and you can work on it separately and then you merge it.
It's what you call it, search and
Amplify.
search and amplify. See, that's the proper process of standardization is not that we dictate to all these guys. It's that we search for the patterns and then we amplify it. We create a new, better, simpler, easier way to do it so that they can all do it. It simultaneously increases the capabilities for all the other packages that haven't yet written this kind of thing. They don't even know it's possible. And now you say, oh my God, we could do this new thing. It's never even occurred
With
to
the
us.
device handler.
But it also drives down the complexity of the system, the sheer volume of crap, cruft, software that has accumulated to try to do this. It now collapses in upon itself in a new, elegant simplicity that allows things to extend. This only works if we maintain the tension between innovation and standardization. The VA, the problem is, tension is uncomfortable. And if you are managing a project like this, you are constantly going to be getting complaints of one or the other. Right? So the VA, having allowed this and developed it and extended it to a great degree in the 90s, began regretting it and backpedaled by stomping out this. They said, no, from now on, everybody's going to do things in the way that we say. Sites, here's a specific example that'll make sense to you from an architectural standpoint. Organizationally, only about 100 of the developers in the VA worked for the national offices. About 900 of them, more or less, worked for the sites. They were on the sites, on the ground, in the hospital, reporting to the director, reporting to the service leaders and the doctors and so on. They could not escape the needs of the users. The users are hovering over them all the time. Why doesn't this work? I want this report, blah, blah, blah. And it caused this massive amount of innovation that was not controlled by central office. So what the VA did starting in the 90s is they realigned to take all those programmers away and make them all report to central office. And
It would be as if in the early days of Wikipedia, they said, we've got to stop
Yes.
this. We're going to get the Encyclopedia Britannica to set up a board.
Yes.
And Wikipedia would have collapsed, of course.
That's exactly right.
Yeah.
That's exactly right. So innovation and standardization. This is one of the two things I wanted to. So this is a specific example of how all you have to do. One of the things that's fascinating is that many things that seem insurmountably difficult when you think about them in terms of I will plan and execute turn out to be absurdly easy to do if you do search and magnify. So you put this back in the picture. All you got to do is put this back in the picture, put the tension back in place. And because it's real tension, because it's not artificial tension on a diagram, because these guys are really at odds with each other, they have to resolve it. And they start resolving it. So you get a couple of people in here programming, you get a couple of people out here programming. It only takes a few of them. And right away, they're going to create this tension, and this life cycle restarts on its own because it's the only way to resolve the tension. It's fascinating.
Yeah, I had a concept.
I got a concept of that I call adaptive stress of an evolutionary system. That how do you minimize the stress of change and evolution? So make it easier to flow and try something and not break everything else. So that the telephone numbering system we have, that where if you overflow an area code, everybody has to change their numbers. That's a high adaptive stress. Domain name system is not adaptive stress, low adaptive stress. So how do you make that as simple as possible and allow the innovation to go out without breaking what's there? And so that's a software engineering problem, but it has to be from the perspective of an evolutionary designer, not clamping down according to hierarchy and having congressional committees designing modules, which is happening today. And so that's a tricky point. I think the triple store, the RDF structures, the semantic web structures are really good for that. And the loose coupling, I also have a concept of future binding, of designing something today for an unknown tomorrow. And we know genomics is coming, we don't know what genomics is going to look like, but we have to adapt to that. So how do you design a module to look at genomics to cope with what's going to happen there? Yeah, that's a good diagram, Rick.
Well, we have to do exactly the same thing in urban planning. We have to design something that's going to work in 10 or 20 years. We have to future-proof it, you know, and we have to figure out what that means in terms of, you know, what the capacity, promoting the capacity of those people who are there to figure it out at that point. There's a couple of really interesting consequences, I think, of what you were just saying. One of which is that it's a different concept of regulation, that we do need regulation, but we need adaptive regulation of the kind that allows you to let these things proliferate and then pull them back in and sort of clean up the process, rather than, oh no, we've got to control the process from the beginning, from the top, as it were. And so much of our discourse these days is about whether to regulate or not regulate, as opposed to how do we regulate, how do we create adaptive regulation that allows things to happen up to a point and then deals with the problem once there's a contextual issue, as biological systems do all the time. Jane Jacobs talks about this too with gentrification and the problem. You know, there's the big debate in the urban planning world about, is gentrification good, is gentrification bad? Her answer is yes, right? Because the things that pull people out of poverty and increase the economic activity of a neighborhood are good up to a point where they, you know, up to a certain point, and then beyond that point they reduce diversity and they begin to create exclusions of populations, and they begin to create real damage to the vitality of that place. It becomes a sort of a boutique, yuppie, you know, upper income enclave kind of place, and loses that vitality that you want. So what's a good process at one stage becomes a bad process at another stage, but it's the same process. So your regulatory process, your regulatory mechanism has to recognize that and has to be able to say, okay, now's the time to take certain steps that will, you know, deal with that. But don't do it any sooner than that. Don't march in and create some kind of, you know, rigid plan for affordable housing or whatever it is that is independent of that kind of process. So, and from the software world, what I know about it, I hear a lot of echoes with my friend Ward and his discussion of not only Wiki but Git and the model of which is very similar. And what he's doing now, by the way, is combining both of those with this federated Wiki, where you let people go off and innovate, and they can innovate to their heart's content. The only issue is, can you pull it back in? And then if you can pull it back in, great. It becomes part of the larger system. If you can't, that's fine too. It just becomes, you know, it goes its own way and goes somewhere else in the system.
I think we should do final comments. Tom, you want to?
Well, I want to thank Michael, first of all, for coming and dropping into this foreign community. Here's a foreigner, we're normal. But I believe me, there are many, many more overlapping topics we had yesterday, and there's just, it's a very rich area for looking at these higher level issues.
We're all designers, right?
Yeah, and I think we're all facing the same issues of hierarchical regulation that's out of date and being impinged upon by network lateral communications and lateral processes. And I guess I'm optimistic that if we can find this virgin territory and get the right people together, we can develop some ideas and get things started in the virgin territory space before the hierarchy finds out about it, and get it big enough to make it happen. And I don't think it's constrained by money. It's constrained by having the right idea, the right initial conditions, and the right fertile territory to make it happen. So, so I guess I'm pretty excited about continuing a small group of people that want to explore this and make it happen. I'm expanding beyond healthcare and sustainability issues, and I'm probably talking about my solar panel problems in San Diego, but why I can't get water from the Pacific with my solar panels beyond me. And so, and, you know, there's just all these topics, and the political divide, the time and time again, you read, it's colliding hierarchies, and to come across with this innovative lateral approach, I think is really rich, and I'm willing to put a lot of intellectual energy into it. In fact, hold some workshops at my home to do it if anyone's interested.
Well, I'll just make it very brief and echo that sentiment that I think there's some, all of these ideas point to the capacity to step into another space or create another space and deal with these challenges. And there's no reason that we can't do that, and that's a pretty exciting and promising opportunity. At the same time, I think Jacobs was right that business as usual is going to kill us at this point. And we really, my friend Dick Jackson, I mentioned earlier, who provided those funny slides, he's the chair of the Environmental Health Sciences at UCLA, and he says it's code blue. You know, we've got to act. So.
Thank you everyone for coming. We'll now break for an hour for lunch.